Alright, so this one's going to be a long one because we got to cover 23.1, 23.2, 23.3, 6.3, and 6.4. So we got a lot to cover tomorrow. So here we go. So basically we're going to be covering minerals and mining and how that whole thing is done, and then we're going to shift to economics and the environment. So one of the big things it's talked about here, I really like this kind of headline there. It talks about mining for cell phones. So as you can see, basically, you can see the miners kind of honestly in the third world countries, they're getting taken advantage of because they're mining for the minerals and for the metal that go into electronics like cell phones. Really interesting read about basically how unfortunately we're taking advantage of everything. So we're going to start basically talking about Earth's mineral resources. So I don't really have too much stuff on these next two pages because basically it's pretty straightforward is what it is. You know, rocks provides the minerals we use. Pretty straightforward. Okay, a rock is a solid aggregation of minerals. A mineral is a naturally occurring solid chemical element or inorganic compound with a crystal surface, so on, so on, so on. Pretty straightforward stuff that I'm confident you guys know about. Okay, it also talks about there in bold mining. I'm confident you guys know what mining is. You know, like we blast rocks to get to the minerals. This picture up here simply talks about the different things that are in everyday life stuff, is all that it talks about. So then this is kind of an interesting little diagram here. I like this one. It talks about at current rates of use, a baby born in 2015, so 5 years ago obviously, is predicted to use over 1.4 million kilograms or 3.1 million pounds of minerals over his or her lifetime. And just like look at all the different things that you're going to use. Like back in the day, you know, think of you're thinking about like you're using gold. Okay, the baby's going to use gold. Back in the day, even the thought of having gold and utilizing gold was impossible. So now moving on to page 632. Again, pretty straightforward stuff here. Okay, so it talks about a metal as a type of chemical element or a mass is such an element that typically is lustrous, opaque, and malleable and can conduct heat and electricity. Again, very straightforward stuff. Okay, the one things we're going to start talking about is things called ore and then smelting. Okay, I'm not sure if you've ever heard of the terminology of smelting. So the picture over here on the right, that's basically smelting. Smelting is basically like you're just like melting the thing is what's going on there. Okay, one of the terminologies they talk about is a thing called tailings. And so that's kind of obviously our first sticky note here is tailings. Pollution from mining that is left over after extraction. And tailings is not like, you know, the air pollution and the water pollution, stuff like that. It's like, it's basically kind of like, think of it as like, kind of like the leftover rocks and leftover solids, kind of stuff like that. Okay, it can also be liquid stuff, but surface impoundments, that's kind of what they use, a holding tank for the waste, because the stuff that they create is pretty toxic. It's pretty harmful. And so they have these big surface impoundments, holding tanks for waste, big old huge things. So you can see this next picture there. The surface impoundment, the Upper Big Branch mine in West Virginia holds coal tailings from a surface mining operation. So it's basically, you can think of it as like it's a really nasty lake, is basically what it is. It's really nasty. Typically they like line this with like literally really thick tarp, and that's how they keep it from getting back into the soil. So now some mining methods that we're going to talk about. Okay, there's a thing called strip mining. What that does is destroys large areas all at once, and refilled areas can erode easily. And there's pictures on the next page I'll show you in a second. So strip mining is basically they're just kind of like digging everything up, finding what they want, and then throwing all the dirt back in there. But since that dirt hasn't been like, you know, compacted over, you know, hundreds and thousands of years, it's really susceptible to erosion. You know, a big storm comes by and will literally just wipe the whole thing out really easily. There's also a thing called acid mine drainage. So that's basically exposed ground reacts with the oxygen and then it rains. And that's really bad. So basically, the exposed ground, so after you do the strip mining, the exposed ground reacts with the oxygen in the air because underneath the soil, you know, going down 10, 20, 30, 100 feet, there's not much oxygen down there. Then the oxygen gets exposed to it, it starts reacting with it, which is really bad, produces sulfuric acid, then it rains, and all that sulfuric acid starts to run off. And as we talked about, the ocean is kind of the end of the river, quote unquote, for everything. So all that sulfuric acid ends up in the river, or ends up in the ocean, I'm sorry. So this is the picture here. There's that strip mining I was talking about. So there's the coal seams. So you go down 10, 20, 30, 40, 100 feet. There's the coal they want. So then they dig out a whole bunch more and they get some more coal. Then once they're done with this, they basically just throw all the dirt back in, and then just unfortunately isn't very solid, so then it starts to get washed away. There's also a thing called subsurface mining, which is the picture on the right. This is basically where they're basically drilling down. Then you can see they drill down, they make little channels to get at the coal. They drill down a little bit farther to get to that one over there, drill down a little bit farther, and so on, so on, so on. Okay, so basically the land on top is still intact. They're basically just drilling straight down rather than just like clearing out a huge, massive portion of the earth. And so this is the sticky note I put here for 635. Is subsurface mining. Shafts are built and tunnels are dug for workers. Obviously, that's very dangerous. You know, the caves implode, or what's the word? They collapse, and basically the workers are killed, unfortunately. Now, this picture here is talking about that acid drainage. So you can see it reacts with oxygen, so it basically turns into basically like a rust color is what's going on. And basically just flows downriver, just flows, flows, flows until it eventually hits the ocean. Real bad news. All right, this was actually really interesting. I like this, the science behind the story thing. Can acid mine drainage reduce fracking's environmental impact? So instead of just letting that stuff just run down to the ocean, utilize it. So what fracking is, basically what fracking is grabbing natural gas. So it's basically, it's a whole bunch of gas stuck underground, and they're basically releasing it and capturing it. But by releasing all of that by releasing all of that gas, you're leaving spots in the ground that now have nothing to like lean on and rest on. So they're proposing here, use that acid mine drainage to basically put back into where the gas used to be. So that way, you know, like think of a whole bunch of ants, all the little tunnels. You take all the ants out, eventually that ground is going to collapse, but they're talking about putting the acid mine drainage back in there, so that way potentially it has something, the ground can be more stable with something on there. All right, 638. Let's zoom back in. All right, so mines have impacts for years after they close. And so the open pit mines, they're basically literally just massive holes in the ground that becomes very toxic over time. Just slowly but surely, all the rain is just washing into them, and eventually it's just getting more and more and more and more and more toxic. This picture here talks about, you can see smoldering mines fire beneath central Pennsylvania have led to the creation of what's called a ghost town. A nearly 1 mile long section of State Route 61 was closed as subsided due to mine fires caused the road to buckle and crack. So basically, this used to be one of the highways, but the fire underground eventually just made it so that thing was starting to collapse on itself. Next thing we're going to talk about is a thing called open pit mining, which you can see the verbiage right there. Open pit mining. So basically, big gigantic hole in the ground, remove the desired ore. So that picture right there, I'm going to zoom in on it a little bit better. That's an open pit mine. Okay, it's the world's largest human-made hole in the ground. So you can see just how many, like, just the roads they stripped slowly but surely, and like they literally just dug a big hole in the ground. And then that bottom right there, stuff starts to pool up and becomes really, really, really toxic over time. You know, because it just naturally rains and then just kind of runs down. So all the minerals and ore and all that kind of different stuff that's in the rock that wasn't exposed now is, and now it's getting really, really concentrated on the bottom. There's another type of mining, a thing called mountaintop removal mining. Okay, and I know I got some sweet drawings here. They're like, this is not cat ears. They're just supposed to be mountains. So you know, like Mountain Peak 1, Mountain Peak 2, and then after the mountaintop removal, now it basically comes like kind of hills and valleys just much, much, much less pronounced than it used to be. So you can see the picture of it right there. And they basically just took off the top of the mountain because they wanted some of the minerals, which, think about like if they started doing that to the Cascade Mountains, like the beauty of our state would start going away because we're starting to get rid of our mountains. All right, so now there's a thing they call it placer mining. I know it looks like placer, Placer, placer mining. It's similar to the gold sifting. I'm not ever sure if you did that. Like I did that in like, I don't even know, third grade. You have the bowl and you kind of like in small circular motions, you kind of move stuff around. That's called gold sifting. It's the same general idea as what they're doing. They're looking for stuff called coltan. And you can see the guy right there. That's basically what they're doing. They're running a little bit of water over it, and basically the heavier coltan will sink to the bottom. All right, there's also a thing called solution mining, where a resource can be dissolved in liquid, it is immersed in it, and then sucked out and filtered. So basically throw a whole bunch of liquid in something, it dissolves, then suck it all back out and filter it. That's another way that they do mining. All right, now we're moving on to reclamation. Zoom in a little bit. So reclamation restores the land to a similar condition before mining occurred. So this is a law from 1872, so a long time ago, obviously, still guides mining activity. So basically, so that way, you need to be able to restore the land after you screw stuff out, or after you screw stuff up. There's a picture of it right there. So you can see kind of the mining stuff that's going on in the background compared to what it used to be. Like just basically the difference between them, unfortunately. Like real stripped apart, but luckily still natural right there. Alrighty, so now we're on 642. So minerals are obviously in a very finite supply, meaning there's not very much of them. There's a limited amount of them. Recycling obviously helps, but the demand for those minerals is faster than the recycling can keep up with. So technology has to advance to keep up. So basically we need to make recycling more efficient, or we need to make stuff that uses less minerals, which is kind of obviously a challenging thing. All right, so you can see some of the things on, what are we at, 643, some of the different technologies or methodologies, discovering new reserves, new extraction technologies, we got changing social and technological dynamics, changing consumption patterns, more recycling. There's just some of the different aspects of it there. Alrighty, I like this thing down here because it talks about like everybody's got phone or cell phones, so it kind of gives it a little bit more of an example. So you can see just the different minerals that go into every single one of all these different phones. Alrighty, so now we're going to jump back to where we go at 6.3. I'm on page 139 now. We're going to be talking about economics and the environment. So there's two different parts here. There's the economy and there's economics. Economy is those are the resources that get made into goods and services. That's the economy. Okay, things that are being bought, those are the goods. If you go out to a restaurant, those are the services. Those are that's the economy. Now the economics portion, that's the study of it and study how people use those resources to provide those goods and services. So two very similar sounding things, but they have a very key difference. So moving to page 140 now. So typically, societies don't factor in what provides the source for goods. So like, when I buy, I don't know, what's the most recent thing I bought on, I bought my parents a Christmas present on Amazon. I don't think about the different, like, things that actually go into it. The different source for it. Like, it's made out of wood, so I assume it's, kind of from America, but, who knows where it actually came from. And so ecological degradation hurts the poor first, and we've talked about that a bunch of different times. If there's an ecological degradation and the land is getting less and less quality, the super rich people, they're not going to be living on that land. That land's value and property value goes down, And so that means that the poor people, unfortunately, they are the only ones that really want it because they can afford it, so they move there. All right, so now there's a thing called classical economics versus neoclassical economics. So classical economics, like it says here, self-interest benefits society as long as laws restrain them. And that's the big thing. You want to basically help yourself, and by helping yourself, it helps everybody else, as long as the law restrains them. Meaning that I can't just like, I'm going to make $1 billion by killing everyone in Idaho. That obviously is not going to benefit society, and the laws restrain me from doing that. Now, there's also the neoclassical economics. That looks at the psychological factors driving consumer choices. And that's honestly, this neoclassical, that's where like the ads on Instagram come up and the ads on Facebook. And, like, I idolize The Rock. And so if The Rock, buys this thing, I have to buy it as well because he does it. That's that psychological thing. And that's where like that's, they use certain brands or like status symbols, like Ferrari and Lamborghini and stuff like that. And so it assumes people are going to behave rationally and have full info. But does the public ever behave rationally? And do we ever have the full info? Of course not. And that's the big flaw with this neoclassical economics part, is that we don't behave rationally and we never are given the full information. And then we move to a thing on 141, or the bottom of 140, talking about cost-benefit analysis. So it works, but not all of the costs and benefits can be easily identified. Meaning that I can't, when I buy stuff on Amazon, I'm not getting that full info on the cost it's hurting potentially somebody else in some other country that I don't know about. And so that's the thing. Amazon doesn't like provide me with, or honestly any company doesn't like provide me with, well, this is a good product, but it hurt this guy over here. They're obviously not going to do that because they're going to make it so their product doesn't sell as much. All right, so there's 4 fundamental assumptions, and I start here with them, and I'm going to go, when we move to the next page, or excuse me, to 144, we'll talk about the other 2. So 4 fundamental assumptions that lead to environmental degradation. First off, we think that we can replace resources. Like, oh, it's fine. It can just, we can recycle it. Everything will be fine. It'll be fine. It'll be fine. It'll be fine. Okay, the external costs. So we're under the assumption that only the buyer and the seller experience the transaction. So overall, like, when I go to McDonald's, I'm thinking, oh, it's I'm being affected, and then the McDonald's company, those are the only guys that are being affected. They own the cattle ranches that give me the beef, they own the dairy farms that give me the cheese, and so on. That's our big, big, big assumption. Now, assumption number 3, now on page 144, this is about discounting. So future goods and services aren't worth as much. So that's kind of the idea that, I'm sorry, I thought I was going to sneeze. Okay, so that's the idea. Oh man, that's the idea that the now is better than the future. So like, I want instant gratification. And so think about like investing over the long term for your retirement. If I put $100 away right now every single month for the rest of my life, I'm going to be a millionaire. But I can take that $100 and I can buy, a ticket to the Seahawks game and stuff like that. That's what they're talking about. So future goods and services aren't worth as much because I want the instant gratification. So economic growth is the big assumption as well. So affluenza occurs when wealth gap increases. So this affluenza, I think, is a really interesting term. Because affluenza is basically like, think of the flu, the fluenza. Affluenza is basically like you get sick with desire to have more stuff. And, I have the right to have more stuff because I live in a first world country. And so therefore I need a better phone. I need a better car. I need a bigger house. I need the new Jordans and so on. That's affluenza. You're just kind of getting overwhelmed with the desire and the need, quote unquote, to have all that different stuff. All right, so now we're moving to 145. So now we're talking about cornucopians versus Cassandras. So they basically this kind of terminology comes with a question which is on 144 actually. Can we conclude then that human ingenuity and technology will allow us to overcome all environmental constraints and continue economic growth indefinitely? If you think yes, you're thinking about cornucopias. You're optimistic. Everything's going to work itself out. We're going to figure it out. We're going to figure it out. Everything's going to be okay. I would think of myself in this bubble because yes, we can figure it out. There is optimism to be had in the future. Okay, I am very optimistic about our future. I know that we're going through a lot of crap, but I think we're going to be fine. It actually comes out of the word literally called horn of plenty in Greek, which I think is an interesting version of like, oh, we're fine, we're fine, we're fine, everything's going to be okay. Now, if you responded no, you're considered a Cassandra. So basically, I don't think that's going to happen, and you're pessimistic about the future, which is kind of a bad way to say it. And so it's basically talking about like there is a limit. Like you can't just go on forever kind of a thing. So that's the cornucopians versus Cassandras. All right, a few more pages. So we got page 148 now. There's non-market value. So this is values not usually in the price of a good or service. So like a scenic drive. So like, on vacation, like, let's take the 101 down the Oregon coast, which if you guys haven't done is a very scenic drive. It's right on the Oregon coast, a real windy little 2-lane highway. Really pretty. There's a bunch of little places to stop and take pictures. So that's what's called non-market value. So, like obviously the cost of building the highway is a certain amount of money, but you can't just, people aren't being charged to drive on the 101. Then there's a thing called a contingent valuation. So this is surveys to see what people will pay to protect something, which is kind of an interesting way to look at stuff. Like if you have the option to like, oh, we're going to destroy the 101, how much would you pay to keep it there? Like, would you pay a toll to drive on the 101? Or would you pay a toll to do, to take care of the forest or stuff like that? Page 149 talks about calculating the value of ecosystem services in dollars makes people appreciate it more. And this is very much like, think about like the air quality. If we had to buy a whole bunch of machines to filter out the air, how much would it cost? If we had to buy a whole bunch of machines to have quality water, how much would it cost? And this chart right there puts that into effect. So like, look at just treating waste. This is total global value per year in trillions of dollars. Treating waste is almost $23 trillion. So if you can actually put that much money into kind of thinking about stuff, it really kind of blows your mind. So you can see the very bottom here, environmental economics have estimated the value of the world's ecosystem services of more than $143 trillion. And that's in 2014 dollars. Inflation is around 2.5%. So it's more than that now. It's 6 years later. So it's a lot of money what our world does for us that unfortunately we don't appreciate. All right, so now we're on to gross domestic product. Okay, basically they talk about like the GDP of a country. That's what they're talking about, the gross domestic product. That is the total monetary value of all goods and all services from that country. So the amount of things we're creating and selling and stuff like that. Then there's a thing called the genuine progress indicator. That differentiates between desirable and undesirable economic activity, which is an interesting way to kind of really decipher what's a good thing for the country, what's the bad thing for the country. So typically, as the name implies, critics don't like that GPI because ideology drives policy. Like if you think that the environment is worth more, then those people that are in power that think the environment is worth more are going to put less money towards the things that somebody who thinks that car manufacturing is more important. So market failure or the crashing of the stock market, think of it that way, can be avoided through government actions. That's a really, really, really important part. Okay, the government has to take a step in. As much as everybody hates the government at times, they have to do a lot of stuff to keep us running. All right, so empowering consumers is a big part of government action. So that leads to companies bending to consumer desires. And this, again, we have talked about this a bunch of times. This is really important, like giving your money or spending your money based on who you want to support. So there's empowering consumers. That's a lot of during this COVID thing, they gave a stimulus check. That was the idea behind it. If we give consumers money, consumers spend the money, and they keep business and the economy thriving, and they keep businesses alive. And one of the things I like here is a thing called greenwashing, which I love greenwashing. This is pretending to be doing best practices, but not actually doing them. So think of in the grocery store, there's the organic section, and then there are things that are just simply labeled natural. Like I love, like my wife loves Fanta, like the soda drink Fanta, where it says it's like 100% natural flavors. Then you flip it over in the back, it says no fruit juice. That's kind of greenwashing. Like you think it's doing well for the environment, but it's just using fancy terms to make you think that. So then we got sustainable development. That's progress that maintains resources. And that's the stuff we want to move towards, is sustainable development. They're doing a really good job of making sure that things can continue to go on forever and again and again and again. Okay? I like this thing on the bottom, this diagram here, this Venn diagram. Sustainable development occurs when social, economic, and environmental goals overlap. And right here, in kind of a real succinct version, this should be environmental science. We take into account the economy, we take into account the social goals, or like the societal impact and how much people will respond to stuff, and the environmental goals. Typically, environmental goals and social goals are typically far apart, but with more education and more kind of exposure to the environmental problems, these social goals are starting to move towards them, thankfully. And then the economic goals, luckily, go along with that as well. Alrighty, so that's the last part of that. Leave some questions, that way we have stuff to talk about.